not moving. So you're just, bro, that's it.
So you need
bro.
two measuring devices to know the actual speed of something, right?
No, you need
one in the ground and one in the airplane.
No, you need a measurement. I don't care
Yeah,
how.
I gave you a measurement
look,
that you refused. You refused the
you
measurement of the ball. Why you refused the measurement of the ball?
I took the measurement of the ball. We measure the ball moving, yes, because when we measure stuff, that's how we know it's moving. So we take that measurement of the ball. Now we know the ball's moving, right? Because we have a measurement of motion. Now we take that logic and we just apply it to the earth. And we go, let's measure the motion of this tree. Oh, well, 0.
But according to you, the measurement's wrong.
Hang on. So now the measurements are wrong.
According to you, yes, because when I measured the speed of the ball, I got 20 miles an hour, and you claim that ball is at 520 miles an hour.
No, well, because
so just by measuring it doesn't tell the actual speed.
Well, no, because you didn't take the total distance. That's your problem.
Oh, yeah, but I take the measurement, right? Yeah. So I agree. I agree with you. I agree with you. But that's not what you said. But that's not what you said. You said you need a measurement.
It is. I've always said it's the distance, the total distance, and you have to measure that, right? So we have a measurement of the plane's distance. We have a measurement of the ball's distance. So we have these measurements of motion, okay? Now, with the Earth, we don't have those. Now, again,
of course, because you're just pointing the measurement device to the airplane while you're in the airplane. So that wouldn't tell you how fast the airplane is moving.
No, and the Earth is not an airplane. Okay, so you can't make the Earth move because an airplane does. That's not how it works. I'm not making that.
I'm just asking you how you distinguish. No, I'm not. I'm just asking how you distinguish.
I told you, with a measurement of the motion of the object. We measure planes moving, right? The plane is not just born in the air. It starts off in the ground, and we can measure its motion, okay? So if you don't have the measurement of motion, you don't have motion, right? And
I don't know how you're getting around this. Having a measurement, because just having a measurement isn't enough. You know that.
What about the 66 million miles per hour that the entire planet's flying through? Do we ever add that in there?
Oh, we are on a flat Earth. You forgot that I'm already a flat Earther, right? I'm a flat Earther.
No. We're talking about your flying ball through space.
I don't believe in a flying ball. I believe in a flat Earth.
1,000 miles per hour. You're flying 66.
Oh, you talk that to ballers.
66 million miles per hour, and then you're rotating at 1,000 miles per hour. You got all these references.
Yeah, that's insane.
References of motion.
That's why I don't believe it. Yeah.
Oh, okay.
I'm a flat Earther now. Forget it.
Oh, you are? I didn't know that.
Oh, yeah.
Are you being...
Hold on. Why is everybody just talking over everybody else? Like, why is all this clipping going on? Can we just go one at a time, please?
I mean, are you being honest right now, Bacon?
Oh, who knows?
Okay.
Anyway, you claimed the way you know it's not moving, you measure the tree, and the tree is not moving. In the same way, I can measure the ball, and they get a speed that is not the speed of the ball. So that's not enough. You have to know the actual distance, right?
We know
how do you know the actual distance? You're appealing to a measuring device.
We have the measurement of the plane because we have measurements of the plane's motion.
Great. How do we measure the Earth's motion?
You can't because it's not moving.
Well, I could make the same claim about the airplane.
No, because the airplane's moving and I can measure it.
Yeah, you can measure it because you have an Earth when you can stand and point the measure device from, pointing to the airplane. You don't have that with the Earth. Wherever you're going to be to measure, to point to the Earth will be on Earth, which means that I'm trying to measure the airplane, being in an airplane.
You're not. Then again, the Earth is not an airplane, right?
Sure. How do you tell that apart?
Okay. How do you tell the Earth from an airplane?
No. How do you tell the motion? Of course.
By measuring it.
How would you measure the motion of the Earth?
It's not moving. So how do you measure something?
Not moving, bud.
How did you measure it? How did you measure it?
I put my tape measure where the tree was, and I pulled it out 12 feet, and I waited an hour. It moved nothing. So.
Sure, it moved nothing. I don't need
to make speculations. I don't need to make wild accusations. I just go with the measurements. 0.
But I'm not asking about the tree. I'm asking about the whole thing.
I did the same thing in an airplane. The toilet didn't move.
Yeah, I tried that. He's just refusing to.
I can measure the ground. I can measure a mountain. I can measure I can measure my house. I can put my drone up. I can watch.
Sure, and I could name many objects inside the airplane that I could measure.
But the Earth is not a plane. See, now you keep.
How do you tell that apart?
By measuring it. Do you know how we know planes move? Because we can
But
measure
all
the
your
motion of the plane.
measurements, all of the measurements you're proposing would be analogous to measure things inside the airplane. You're not telling this apart. Yes?
You're making Earth an airplane.
No, I'm asking how you tell that apart. That's all I'm asking.
By measuring it.
Because you're not in a fucking airplane, bro.
But the way
Jesus
you're proposing
Christ.
to measure it, would be analogous to measuring things inside the airplane.
If you want to say that there's something on the Earth if you want to say that something on the Earth is moving or the Earth is moving, it's very simple. Very easy to do. All you have to do is measure the distance it traveled. Now, if you can't show me the distance that the Earth traveled, but you can show me the distance a plane traveled, I'm going to say, great. Hang on. You've established that the plane is moving. Yes. But you've never established that the Earth is moving. And don't ask me how, bro, because if you can't show me how you measured the Earth moving, the Earth isn't moving. All you have is your beliefs and an if.
I don't believe that.
And even if you said that it was
the measurement. So show me the measurement of it moving.
Even if you said that it was moving.
No, I didn't say the Earth is moving.
No, even if you said that it did, I could just say, no, it's not from my frame of reference. So there is no such thing as motion.
So, yeah, but we are playing under the assumption of a global frame of reference, which is...
No, you are. You are.
I'm basing it on empirical
fact.
Well, you said actual position without...
Bacon?
Sorry?
I think Earth's an ice cream cone. How do you prove that it's not?
Well, I don't see...
You can measure it.
I think it's a triple scoop. I think it's a triple. Well, yeah, you just haven't dug deep enough. There's a bunch of dirt on top. It got dropped. So, but there's ice cream down
it could be. I don't know how to refute that.
Well,
since we don't know how to refute that, can we continue where we stopped?
So what?
Or do you have a relevant
point? Do you want to continue on? Oh, is it an airplane or an ice cream cone?
Oh, I'm not asking if it is an airplane. I'm asking how would you tell apart with that analogy. So if the whole
how do you know the difference between an ice cream cone and an airplane?
There is no how you could tell. Is it moving or is it not? No.
What if I throw my ice cream cone in the air? How do you know it's not an airplane?
When you claim things are or aren't, you have to be able to know that.
The
way you know that is observing.
Again, you're switching claim. You're making a measurement a claim. A measurement is not.
Oh, you are.
Hang on. Wait. Let me finish this. If I said I claim my table's 48 inches, that would be a claim. If I then grabbed a ruler or a tape measure and measured it as 48 inches, that is establishing the fact that it is 48 inches. Now, if I'm going to say that tree, which is connected to the Earth, is not moving, and then I go and measure it, not a claim anymore. It's a measurement, empirical fact.
Okay, so by measuring the speed of the ball, I can tell whether or not the ball is moving or not, right?
And by measuring the plane, and that's how you measure if things are moving.
Okay, but you're just adding something extra.
No,
you're not realizing it.
What you're trying to do is you don't have a measurement of the Earth moving, and I have a measurement of the Earth not moving. So
actually, you don't.
Hang on. All of the facts are on my side, right? I have the measurements. I have all these zeros. I have everything. You have nothing. You don't have one. Hang on. You don't have any measurements of Earth motion. You have.
But I'm not claiming that.
Okay, so we're at the Earth has not been measured to move. So without a measurement, you're not going to get it to move. You can move a plane.
I'm not trying to get it to move.
A ball. Okay, so what are you trying? So that's fine. I don't. So
okay.
Pretty much wrapped it up.
Okay,
the Earth is not moving. You can't prove it is moving.
I agree. Okay, wait. I agree. All your measurements are compatible with a stationary Earth. I agree with that.
So then they can't be compatible with a non-stationary Earth either.
Now I want to know if those measurements guarantee that it is not moving. And if the outcomes of those measurements are exactly the same independently of Earth's movement, those measurements are irrelevant of the Earth.
What motion? Where did you measure motion of Earth?
I'm not claiming motion of Earth. I'm asking how could I know if it's moving or not?
By measuring it, and you don't have
that. But your measurements don't tell it apart. I don't know how can you extinguish that.
No. The measurements are the measurements. What you extrapolate from that's your personal bullshit, right?
I'm not extrapolating. I'm asking you how the
No,
He's
you
telling
look,
those
look.
questions are-
Asking a question doesn't make Earth move. So right now, I'm okay with just ending this at I have 0 measurements for Earth motion and you having a whole bunch of hypothetical questions. Because that just shows you that you don't have any measurements of Earth moving. And I do have measurements of Earth not moving. And all you can really do is bring up a hypothetical situation, which is not reality.
Because I'm trying to know if that hypothetical is true or not. And you have no measurement that can distinguish between that being true or not.
That's you. The measurements don't distinct. The measurement is the designation between moving and not moving. So when we measure 0, that's not moving. When we measure not 0, that's moving.
Actually, not, because I already gave you an example in which you can measure a value which is not the actual velocity of that object.
That's measuring, right? So when you get zeros, right? Because you got values.
Not the speed of the ball.
Hang on.
The speed of the ball, you're asking me to add an extra measurement.
But not see. Measure the Earth, not a plane, please. Now, every time it's almost like you're brainwashed.
It's just an example.
Hang on, wait. No, it's your hypnotism, right? You don't have measurements of Earth moving. So, but you believe Earth moves. So how do you make Earth move when it's not moving? Well, you move a plane, then get in the plane, then ignore the outside, then say you're not moving, then translate that back to the Earth and make the Earth move. But without a measurement, just your hypothetical situation.
Okay, I lost myself. All right.
Dude, the whole concept of measurement requires some kind of fixed point. So even if you said we measured it, you didn't, because nothing is still. So
that's my point.
Yeah, so there's no way to measure anything with your model.
It is
not
possible.
No, there is, but Jerry,
everything's moving all the time. There's no fixed point.
I agree that there is no objective way to measure things in my understanding of motion. So every measurement that you're taking under my understanding of motion will be relative. But you can't refute that because that is compatible.
So you can't make any you can't make any claims about anything.
No, because you need to give a reference frame to make the claim. And as soon as you give, that's no longer a relative claim. That becomes an objective claim. So for example, if I just claim that the airplane is at 500 miles an hour, yeah, I can change the reference frame to make that become true or false. But if I say that airplane is 500 miles an hour in the reference frame of the ground, that's no longer up to debate. That's false or true, period.
But then you're abandoning your entire premise of no fixed points. It's back and forth, back and forth.
No, it's not. Where am I implying a fixed point?
To measure something, you need a fixed starting point.
I need a frame of reference, which might or might not be fixed. It's relevant.
Well, then you're not measuring anything.
I am.
All right.
Because we all share the same frame of reference, so it's very useful to use that as the default. So when we say that a car is at 20 miles an hour, or I don't know, I have no notion of miles an hour, but that's usually implicitly using the ground as a frame of reference. So if someone is going to measure the speed of the car, that person will be on the ground, and that person won't be running in the ground. It will be still in the ground. So that person is in the same frame of reference of the ground.
When a car runs its speedometer, it's ran off. It's the rotation of the flywheel has nothing to do with the ground. It's all about the RPM.
I'm talking about a person measuring. I'm talking about a person measuring the speed of the car.
Yeah, they don't measure the speed of the car with the tape measure. They measure it with the radar gun or with the chronometer.
Exactly. And if you try to use a radar gun in a moving surface, that movement will be subtracted in your measurement. Whatever you measure will have that movement subtracted to it. So you don't know whether or not there is something being subtracted from your measurement.
But I don't know, man. This just sounds like a silly argument to begin with.
No, I'm just saying you don't know. If you're claiming you do know, I'm asking how do you know?
If you're gonna say you don't know if something's moving, I don't know if you can say anything at all.
Well, I know if as soon as you give me a reference frame, which is usually the ground.
66 million miles per hour, bro. That's what you think the ball's flying through the space at, all right? Game over.
How did they measure that 66,000 miles an hour?
Well, I don't
I think
know.
it's
I'm not a
million.
glober.
Is it 1,000 or is it million?
You
I
forgot
would-
about
You're a
bro,
that.
sure thing, kid.
All I would
You're a
just, you know,
glober through and through, kid. I smell it on your breath.
look, whether I could care less what he is. I just, you know, all I would want is the measurements to back the claim, right? Whatever the claim is, if you're going to claim that a baseball is moving 300 miles an hour, you're going to claim that a fence is 250 feet
That
long.
was never my
Just show me
claim.
the measurement. Just show me the measurement.
I'll repeat my claim. My claim is you can't distinguish between those two hypotheses. The Earth being static and the Earth moving 500 miles an hour. You can't distinguish between them. And every proposal you gave to try to measure the speed of the Earth would give the exact same outcome in both hypotheses. So they aren't telling you them apart.
You're living in a hypothesis, right? We don't live in a hypothesis, right? We live in reality. Do you agree with that? Yes or no?
Sure, yeah.
Okay, so in reality, when we measure the Earth, we get the zero value. Now, your hypothesis, not reality. So we're not going to go
in
there.
our hypothesis, in my hypothesis,
You-
you would still get zero value.
No, but your hypothesis is not reality.
How do you
right? So
know?
we're throwing, because you just made it up, right? So I don't care about your imagination. I care about reality. Now, in reality, Earth measured zero motion. Now, like I said again, you only have a hypothesis. You only have hypotheticals. You don't have measurements. And you're trying to tell me that my measurements...
But I never claimed it's moving.
You're telling me my measurements are empirical because of your hypothetical situation.
No, I'm telling you your measurements.
The hypothesis, Bacon, has
Don't
to
give you
be
the
grounded in
conclusion that you
logic.
want.
Bacon, you can't just make false hypotheses based on nothing that shows indications
Is it a false?
of yeah, like I can say we're riding on an ice cream cone, but I could say we're riding on an ice cream cone, and there's nothing that you can do to validate that or devalidate.
So I can't say it's a false hypothesis if I can't invalidate it.
Yeah, you can't invalidate that we're living on an ice cream cone. You can't dig deep enough to tell me that there's no ice cream down there. If I say there's ice cream down at the center of the fucking earth and it's flowing around until you core down there, you're gonna sit here and have to go along with my bullshit. Does that sound logical?
Well, I'm not gonna assume it's true, but I'm also not gonna say it's false just because I
not logical.
Don't.
This is where logic is implicative, bud. You can't just throw around.
No, things aren't
like this.
Things aren't logically false by default.
You're throwing around feelings and thoughts without any rational logic to support it. That's how hypotheses work.
I don't know what you're talking about at this point.
You're saying the Earth is moving, but you have nothing to validate that.
No, I'm not. I'm just trying to figure it out.
He's just saying you can't
tell you it's not moving, but you don't want to accept that. So you have to have something.
Get you from your word. I'm a man of science. I want evidence, right?
So give us evidence. Give us your evidence to support your contrary.
I'm not making a claim.
You did. We gave you the evidence. You denied it. That's a claim.
Yeah, that claim, yes. Not the claim that the Earth is moving. The claim that my claim is that your measurements are compatible with the moving Earth.
Yeah, the Earth is not moving. You say it is. You have to have something to support that.
I'm
you
not
can't
saying
just
it is.
say.
No. You're misquoting me. I'm not saying it is. I'm just asking, how can I figure it out? I'm curious. I'm a curious flat earther.
It's logically implied.
Okay, show me your deduction.
Yeah, we have what's called an equilibrium within our inner ear.
Oh, here it comes.
Shows no motion.
Yeah, it does the same thing in a Concorde that's traveling 2,000 miles per hour.
Yep, this is why I want
in an enclosed system.
This is why I want the measured distance, which they never have. This is why I take this particular route, because they have no measurements, so they cannot go against my measurements with measurements, and measurements are empirical.
Yeah, I'm not claiming you're wrong, because I'm not claiming you're wrong.
Your hypothetical doesn't negate, right? You can't say your measurements are false because I have a hypothetical situation in which
correct. I agree with you.
Okay,
and I'm not doing that.
So hypotheticals are irrelevant. So we just
stick
with the measurements.
No, they aren't.
Yes. A hypothetical is useless. You can't use a hypothetical to prove reality. You use reality to prove reality.
Sure, and you use reality to know things. And if there are two possibilities, you have to be able to distinguish between them. If there are two possibilities, you have to.
The possibilities are hypothetical, right?
Well, they're possible, right? They're by definition possible because they're possibilities.
It's your hypothetical.
Okay, would you agree that it's possible?
It's your hypothetical.
Okay, it's my hypothetical. Is it possible?
Yeah, but not reality.
Is it possible?
No, hypotheticals are not possible.
If I make a hypothesis, it's just because it's a hypothesis, it's impossible. So if I'm hypothesizing whether or not you're straight, that makes it impossible for you to be straight.
No, your hypothesis is not reality, so it's irrelevant, right? To reality.
I'm not asking if it's relevant.
Hold on. If you hypothesize that I could fly, it's irrelevant. Irrelevant. If you hypothesize whatever, irrelevant.
You give me irrelevant hypothesis. Of course, they're going to be irrelevant.
No, I'm not giving. I don't do hypothesis because hypothesis is a guess, and now I don't guess. I measure. All right, I don't guess if a tree is moving. I measure that the tree isn't moving.
That's cool.
Why
that's not what you're measuring.
There's your answer, Bacon.
Sorry.
How do you know if there's an earthquake? Is the Earth moving? Because in relation to Earth, it doesn't move because the whole Earth is moving. So is earthquake Earth movement?
Yeah, seismic activity. You ever heard of a seismograph that measures the motion of the Earth? Yeah.
No, it measures the motion of the seismograph.
When that's showing zero, the Earth's not moving. You know how we know what magnitude an earthquake is?
That's pretty good.
We measure it.
Sure.
That's a great point, Mailman just did.
When a gyro picks up motion, it is moving. Yeah.
The Earth did move once when back in '96 it was pretty rapid, pretty violently shaken, and then it stopped.
Yeah, and when Bob measured the rotation with the gyro, yeah, it moved. Yeah, sure.
He didn't measure rotation. There was no. He got a value on a display on a screen.
Not from the reference frame of the gyroscope.
Just like you said, just like you with the seismograph. Yeah.
A gyro doesn't measure doesn't detect motion. It detects.
It does. It does though.
If we're in an earthquake, right, and things are starting to go up and down in my room, my keyboard is going up and down.
How would you
everything's going up and down, right? But the ground is.
I have a hypothesis that you were just dreaming.
How would you know if
things
the keyboard's going up and down?
Things are jumping on my table.
Well, how do you know they're jumping?
Well, I see them jumping on my table. That's my observation.
How do you know? Wait, hold on. How do you tell the difference between your keyboard jumping around and your keyboard not jumping around? Or let me ask you more simpler.
That's what I asked you actually.
Well, you just said that your keyboard's jumping around.
Can't ask a question with a question.
How do you know that your keyboard's jumping around? How can you determine that?
Because my eyes are moving up and down if I try to look at it.
But from the reference frame of
your eyes lie to you all the time.
Yeah. But I'm asking you now.
From the reference frame of the keyboard, it wasn't moving at all. Nothing moves.
Yeah, agree. Yeah, but I'm not using the reference frame.
There's all these frames of reference.
I'm not using the reference frame on the keyboard. I'm using mine, right?
Okay.
Yep.
No, not your reference frame. Not the reference frame of the keyboard. In reality, did it move? That's it.
Well, you tell me.
That.
Actually,
no, I'm not going to tell you from my frame of reference.
Okay, so
I don't get your point here. Let me.
My point is, shit is moving or it's not. Period. There is no.
And how do you tell? Or not?
No, there is no how do you tell? Is it moving?
You just assume that. It's just your assumption.
You measure it. You want to know if something's moving? You measure it. No measurement, no movement.
Thanks, Bob.
Sure, but
how do you know you weren't dreaming?
The measurement varies depending on the speed of your measuring device.
I think you were just dreaming.
Measure the motion of the Earth with a gyro on it.
Yeah, but from the reference frame of the gyro, nothing was moving.
Sure.
Yeah.
Yep. Well,
yeah, but
actually, the light.
So from the reference frame of the light, nothing was moving.
From the reference frame, what?
From the reference frame of the light was still.
Everything moves.
the gyro.
The light is moving against the gyro. Side.
Oh, we're talking about linear motion for now. I think gyros are just going to
No.
add
Oh, how
some
do you know the difference
necessary
between linear
complexity.
motion and any other motion?
Sorry?
How can you tell linear from any other motion?
You measure it.
With a pendulum, for example.
But from
Yeah,
the
but,
reference frame of the pendulum, it's sitting perfectly still.
Exactly.
Right. So there is no such thing as motion, bro.
Yeah, what are you talking about? Everything's just
I
staying
never
still,
said
man.
there's no such thing as motion. There's no such
It's
thing as
all
absolute
reference
motion.
frames,
No, but rotation isn't about linear motion.
but
That's
not from
different.
the reference frame of the Earth. The Earth
No,
is still from
it's
its own
different.
reference frame.
If something is accelerating, that acceleration would be the
How do you
same
know
for
it's
every reference frame.
how do you know it's rotating and not just going into a vortex?
I'm not claiming it's rotating. I'm a flat earther. I
don't
just want
think
to
you
know
are.
whether or not the Earth is moving 500 miles
How
an
do you
hour.
know you're a flat earther?
Because I failed high school.
I have a hypothesis that says you're not.
Yeah, you're right. I didn't fail high school.
If you were a flat earther or a non-stationary earther or a stationary earther, right? Wouldn't your like strongest argument be that there's no measurement of motion? Wouldn't you say that would probably be the strongest argument?
No, it would be an argument if that claim actually would tell apart against the antithesis of this, but it doesn't.
You're a flat earth. You're arguing. You're trying to convince people that the Earth is not moving, right? So let's just say me and you, we're new flat earthers to this. I know we're not flat. But now we get to this person, and he's like, I think the Earth is moving, and we go, but look, we have all these zero values, right? Like for no motion. Like that's what I would say to him, and then he would have to go, but what if? And I would go, well, what if is not reality, right? Just like what I'm doing with you. So we stick to reality.
Okay, so what's our point? I mean,
the point is that in reality, the only thing we have, is the zero measurement.
Yeah, he's measuring the Earth's
zero
motion
measurement
against the Earth.
Zero measurement
So
isn't making. Sorry, go on.
Yeah, I'm just saying that he says that he's measuring the Earth motion against the Earth. So basically, he can't say that earthquakes are Earth moving because he can't measure the motion of the Earth.
No, you can't say that.
You measure earthquakes. How do you know? That's how we know earthquakes happen, dude. Because we can feel, which we measure, right? So if the Earth is not shaking in terms of an earthquake, right? You have the earthquake thing and then normal, right? Yeah, that's how we tell the difference with the measurements.
Actually, if you would fix a the radio gun in the ground and a earthquake started, you wouldn't peak motion on the ground. You would peak motion on everything else but the ground.
Yeah, and there's no distance.
Things will be moving, not the ground, because that's
Wait, if
you have to disattach
if the stick is in the ground and it's moving, right? Like, isn't the ground moving with the stick to make the stick move?
How do you know that the stick is moving?
Because we measured it.
With what?
Well, you can where it was and how it moved. How do we measure it? How do we measure anything, right? And this is the point.
Yeah, how do you measure an earthquake?
You assume a fixed point of 0, and then you watch for any deviation.
How do you measure
can't do that.
A ruler? Is there
Rulers
any measure upon a measure?
Yeah, you can't measure a ruler. I mean, sure you can.
This went way further than it needed to.
Yeah.
But anyway.
Yeah. But yeah.
You guys have a rest of your day. Good rest of your day.
Take care, dude.
Thank you.
Yikes.
I mean, it is interesting with this. I'm sorry, go on.
Did someone say yikes?
Yeah, I said yikes. That was some cringe.
Yeah.
You guys totally entertained him trolling, pretending to be flat Earth when it was obvious he was just trolling for like 2 hours.
Probably, yeah. I mean, with this new idea of motion, it's very interesting. Like you can't have top speeds for boats or airplanes anymore. I like that.
This is the one thing too. If someone, oh,
Go ahead.
sorry.
Sorry.
Okay.
Go ahead.
Well, say if someone says like, "Hey, I'm going to LARP as a glober right now. Now convince me it's a globe." Well, right there, you just say you're LARPing as a glober. There you go. That's your proof that it's a globe. Like, convince me of something I already think.
I want to
Like-
quote a quick quote real quick by Ken Wheeler. He says, "No one can measure that which measures. No one can measure that which measures. Furthermore, the entire world lives upon that which not a single being can measure. The entire world is built upon and rooted on in love, fear, hope, faith, desire, hatred, and much more. The foolish many who deny the existence of what cannot be measured are to be shunned." I don't know. I just thought
it was good to the last part. The shunning part is kind of like, ugh.
Well, even though I disagree with Ken right there, I do. I got to commend you because that's the first time that you've quoted Ken Wheeler and announced it beforehand.
Oh, yeah, okay. Well, this was a
Yeah.
direct quote. This wasn't a definition of his. This was like part of his actual, I don't know,
Bible.
ontology.
But honestly,
Yeah,
I
Bible.
think it was kind of it had. I don't know if you can sound profound, but it sounded profound. I just don't agree with what he said. Like it's very poetic, it's very nice sounding, but I don't agree that we live on something we can't measure personally.
If you like Wheeler, check out Bill Gaedy.
What is it, Bill? What?
Gaede, I believe.
Why does that
Yeah,
name
look
sound
him up
familiar?
right now.
Because he's a baller, but his idea of gravity is different than most people's.
Well, I don't know all ballers, but that name does sound fairly familiar. Go check it out.
I've brought him up a couple times. He has a
he-
type thing.
It might honestly be from you bringing him up then. Hold on, let me see.
Does he have the same idea as Ken Wheeler about gravity?
He actually disagrees with Ken Wheeler, which is why I was saying I think you should. And he doesn't just say Ken Wheeler's a stupid idiot. You know, as articulate as Ken Wheeler is, Bill Gaedy is even more so.
How do you spell his last name?
Geade.
It's G. It's if this is the same guy, his YouTube channel is B, and then it's Gaede.
Yeah, that sounds like him.
He's got a video that says, "What is time?"
Yep.
Time doesn't exist. He gets into masculinity and women stuff.
Yeah, extinction, end of humanity. You know,
Velocity or speed of light. Yeah, sounds probably like the guy you're talking about. So.
Yeah, that's definitely him. Yeah, he doesn't believe in the speed of light. He doesn't. Well, he knows there's no speed of light. He knows. But again, he does. He believes a lot of baller things, but the thing is, he explains them logically, right? Like he doesn't have orbits. He has like a connection between Earth and all the other things. So that's the mechanism, right? It's not just gravity. It is this type of thing.
What does he say about the speed of light or the light? Does he travel at all?
Yeah,
No,
it sounds like
light.
It sounds like he's given two propositions: velocity or speed of light. So he sounds like he's implying that it is an emission. So I don't know.
For him, instead of he doesn't again, he's not a photon guy, so he has his string theory. Now, instead of the photon moving in a wave, you have a string which is a wave, and that's how light moves instantaneous, because it's like if you pull a rope, right? We feel it. We can instantly get the reaction, right, from one side to the other, and light works the same way instantly, like the pulling or pushing of a rope or twisting of a rope.
You know that's not true though.
Yeah, that's not true. Yeah.
You can't feel the rope right when you pull it.
If the rope is taut, yes, it is true.
No.
So
Not
you're
even was
telling
made
me,
out of titanium steel.
bro, if we had a taut rope, right, from us, me and you, there's no slack in it. And it's a mile long. We're holding it.
It sounds like
You're-
you guys never been fishing, man. How do you think I know when I got a fish on the end of my line when it's fucking a couple 100 feet away? It's because the line's
Take it away.
taut and the vibration passes through. You guys never talk to each other through a cup
At
and a
what
string
speed?
as a kid?
Yeah, and
At what speed is there vibration?
Faster than the speed
Yeah.
of light, or slower?
No.
Have you ever? This is where
At what speed do vibrations move through things?
It wasn't instantaneous action at a distance, but it definitely propagated through the string.
And also remember
Well,
that.
think about it. You said it best when you said vibrations. I just trying to think what speed of vibration moves through material, and then you'll be out.
Yeah, it depends on the medium. Light vibrates through the ether, and sound vibrates through the air, the atmos.
Yeah, but what do you said about the rope, though? You got a rope, or if you have a stick and you're poking something, that's like what we're talking about. Like, what speed does it take for you to pull the stick for the other end to respond?
If it's a mechanical tug, yeah, it'll be a delay for sure, but it's the elasticity of the medium and like he said, the tautness, and I mean, there's probably some factors, but yeah, there'll be a delay. Why are we even talking about this again?
Well, because he was talking about the speed at which you pull a string on something, you feel the other end. He used it as an analogy, but the truth is you don't feel it on the other end instantly. It moves through the rope at the speed of sound.
Maybe you'll feel it at, quote, the speed of sound. It would be damn fast, right?
So if you had something rigid, right, like a pole broomstick that was 2 miles long, and you pushed on one end of the broomstick, the other end is going to automatically react instantly.
That's what me and Mole Man are disagreeing with.
No.
I think
I'm gonna let Mole Man take it away though, because
it's instant, buddy.
Well, you even just said it yourself. We just agreed on that about the vibration.
we were talking about the rope because the rope isn't as rigid as a pole would be. So that's why I said it. There's some variables there.
Alright, so if you let's say you're fishing with for some reason instead of string, it was actually a rod or something like that, and the fish pulled on the rod, you're saying you would feel it immediately.
So if it pulled on the rod, yeah. If it flicked the rod, then that vibration passing through that rod would take time. There would be a delay. But if it pushed the rod or pulled the rod, that's instant.
Okay, what if it pulled the rod? So if it pulled the rod, you'd feel it instantly. What if it pulled the rod almost the force that it took to actually pull you, but it wasn't enough to pull you, so it didn't actually move the rod, but there was force acting on the rod? Would you feel that instantly?
You're asking if he would feel the non-motion of the stick?
No. If he's holding the rod, he's holding it, so it's not actually it's not enough to actually,
I see
to
what
move
you're
it or
saying.
anything, but it's enough for him to feel that he has to exert force.
I don't know. I mean, that's a good question.
That's
That
what I'm
probably
saying.
would determine how tight I'm holding it. Like if I'm loosely holding it to where I could feel that flip through my hands, then probably. But if I'm holding it tight and it's not enough force to pull it completely, I don't know if I would notice it, but they would be there. It'd be present.
It's not intuitive, and I remember the first time. It's like one of those things that you hear for the first time, and it's not intuitive, so you don't believe it. But it was intuitive to you at first because you said the thing about vibrations. But that's honestly the truth of it. That if you had a stick that was from here to the moon, and somebody poked one end of it, it would take the speed of sound through the object for the other end of the object to actually move. That's just the truth of it.
I think if let's say you had a metal rod, right, and you banged it, right, a metal rod from here to the earth, from Earth to wherever the fuck you think the moon is, and you like tinged it, right? Yeah, that vibration, because it has to go from one end to the other end. It has to move the material. But when you move the entire material, right? Like if you move that entire rod, that is not a vibration. You move the entire structure, and since the structure is connected to itself, one end will move with the other end.
It's instantaneous. As instant as you move one end, the other end will move just as instant.
Like a magnet.
Well, I want to clarify something. Just for a question for you guys, Because if I remember correctly, both you guys are two guys who don't really. I know you guys don't believe in electrons. I know, right, Dan, you don't believe in most atoms or whatever. But neither of you guys believe in like the atomic structure, or molecules, or stuff like that. Or
No, I didn't say that. I believe in the
that's what
atom.
I'm trying
I
to find
just
out.
deny the. I don't deny the atom. I deny the electron and the photon.
I deny
Okay.
And your graviton and your virtual particle.
Yeah, I believe in quote atoms, but they're not the mechanism that you think it is, right? For me, the nucleus would be where a lot of these ropes intersect, and the outer edge would be where a few of them intersect. Like, so the middle would be like where you have a lot of intersections or a lot of structure, and then just on the edges. So it's just, I guess it's
Like
how
a rope density.
Oh yeah, but that would be, you know, like the nucleus kind of thing. That's where you would have more things.
Well, the reason I'm clearing that up is because, like I said, in the way that I understand it, I'm trying to describe it is the molecules, which you can think about anything like a crystalline structure or whatever, of like the molecules connecting, of a rope, of a metal rod, of anything. When you move it, like when you move one end of it, the actual atoms in the structure have to communicate that to the atoms right next to it, in order, for that movement to occur. That sounds, it sounds silly maybe, but that's, in my understanding, what's happening. That's why it moves at the speed of sound, because you actually have to push one end of the rod, and then all the atoms are like, relating, or responding to the ones right next to them, in order for the other end to feel it.
Like dominoes.
Yeah, I mean, I guess like dominoes, or like, yeah, I mean, that's probably this is the way I think about it. But that's the way in which it was kind of explained to me at one point or whatever. But I totally understand it's not intuitive or even believable, because it sounds like if you have a stick from here to the moon, if you poke it, it'll poke the moon immediately. But supposedly the mainstream explanation is it takes the speed of sound through that material for it to respond to the.
Yeah, I think the vibration would take the speed of sound to move through the object, but you can move the object faster than the speed of sound. So clearly,
I wonder if there's a way that could be tested.
Yeah, bro.
What's that? Yeah, scalar
the
wave
speed of
technology, man.
Yeah,
That's
objects are broken
that
the
was
speed of
Nikola
sound.
Tesla's death ray. It's instantaneous action at a distance. At long distance.
It's using the mechanism of magnetism. I mean, look at magnets.
Just transverse scalar waves.
They have a instantaneous action at a distance, right? Also, because think of it.
Well, this is over like several miles. Like I'm saying, like
a strong enough magnet could, right? If you had magnet makes what is like, you guys say it's this field, but it's this area of influence around it. Now that area of influence acts immediately, right? The moment a piece of metal gets within that under the influence of the area, it's boom, it's attraction. The attraction starts.
Well, the field's there automatically, and the second something comes within proximity, then yeah.
Yeah, it starts interacting. Like they interact immediately with each other.
Yeah, but the thing is the magnetic field goes way further than what's actually picked up on a Gauss meter, or by the interaction between the opposing and the repulsion and attraction forces of the magnet. Like you could see the magnet interacting with the ether from like, I think it's been recorded up to 80 feet away. Science can't explain that.
Just kind of.
I mean, are you sure? Because I think.
Yeah.
Gravity.
I told you the experiment you could do to test this yourself. It's pretty cheap.
I believe it. I'm saying I don't think that science can't explain it. I think electromagnet attraction, and also
the magnetic field from current science is within said proximity of what the Gauss meter picks up on the flux, and Outside that, there's nothing to be measured. So why is it that we're still seeing a phenomena of field disparity at these distances when this far exceeds the said magnetic field that you know of?
I mean, when does the magnetic attraction go to zero? Because the equation doesn't
like 11 to 12 inches. I mean, depending on the size of the magnet, but roughly 11 to 12 inches.
Could it be?
I thought it was never.
Yeah,
I
that's,
thought it was.
Oh,
It
it's
just
you
keeps
can't if you were to
dropping
take a
at an
Gauss
exponential
meter
rate,
to
but
try
it's
to measure the
effectively zero.
flux. You have to be within 11 to 12 inches roughly to pick up any kind of flux on it, depending on the strength of the magnet. But again, like, no one's ever picked up a fucking flux reading at those distances.
Right, but are we talking the difference between it exists and it's detectable?
What?
Are we talking about the distance between the existence or the detectability or something?
Yeah, the distance of the phenomena, the flux reading, what we know about.
the measurement.
This is
right?
why, yeah, all
You
of it.
can't say
But
that the magnetic field goes further than where you can measure it. 'Cause
well,
the-
this is the dielectric field. This is what breeds the magnetic field, is the loss of the dielectric field. So what you're seeing at those distances is literally the dielectric component of the magnetic field. But science doesn't want to tell you that.
The field, like if you're trying to measure, if you're trying to calculate magnetic attraction, or you're trying to measure the field of magnetic attraction between two charges or two objects with charge, it's never going to be zero. It doesn't decrease to zero ever. It just gets infinitely small.
Yeah, it does. Tried reading a fucking. I'll hold my magnet up. You get your Gauss meter and you tell me if you can get a reading.
That's what I'm saying.
It doesn't ever go to zero. If the magnetic field goes forever, you go ahead and get your. I'll tell you where to point it and go ahead and start reading.
But again, this is what I'm saying. It sounds like you're talking about whether something is a certain way or whether it can be detected.
So
unless you're saying it can detect infinitely small amounts of magnification, but that would be because all you need to do is invoke infinite, and you clearly have to say no, it's not able to detect infinitely small amounts of magnetic attraction.
It's because it's not a quantitative attribute. Magnetism is a qualitative attribute.
You can't quantify a magnetic attraction. I misunderstood you.
It's yeah. So before an object becomes a magnet versus after it becomes a magnet, there's no anatomical or molecular change. It's only within its qualitative attribute that defines a magnet to be a substance.
Right, but when we're talking about measuring something, we're obviously talking about quantitative.
Sure. And when we're measuring it with your Gauss meter, it's only at said distance that it's picked up. And then when you try to test the phenomena with a piece of metal or something else, like, you're only going to pick it up at a said distance.
So is it at the point at which the Gauss meter is reading zero, is that where we would say with absolute certainty that the magnetic attraction is also zero?
Well, you're never going to pick up a magnetic reading of flux at the center of a magnet anyway, because it's always at the outer extremity, the plane of inertia. This is where you're going to get the flux reading. But yeah, this is all within said proximity.
But the question was, at the point that a Gauss meter shows zero, are we certain that the magnetic attraction is also zero, or just that it is
Correct.
so low the Gauss meter is no longer able to read it?
Yeah, it's
so there's
zero, if not near zero. I mean, nothing's absolute in certainty, but it's good enough to say there's no phenomenon reaction taking place. There's no iron filings doing anything to show the indication of, like,
right.
So unless it's a strong enough magnetic field. Huh?
So you're saying near enough, but not exact.
Yeah, it falls off. The magnetic field falls off, just like your supposed gravitational field.
Yeah, you're exactly right. You're exactly right. It's just like the gravitational field falls off. Well, one's a squared function and one's a cubed function, but they fall off. When you put a cube at the bottom of a fraction or a square at the bottom of a fraction in the case of gravity, it'll get increasingly smaller, but it never gets to 0 is the point.
Yeah, but then one's functional and then one's practical. One's practical and functional, the other one we can't even detect.
Well, you can't detect.
Nobody can.
Right.
Yeah,
Alright.
stop being silly.
But it's detectable, just not by a device that we have. But it's there. It is
Oh,
a
yeah.
value less
How is it
greater than
detectable?
0.
You're gonna use my
Well,
experiment
it's
to
a value
detect it?
greater than 0. No, I'm saying it's a value greater than 0. That's the
Then
that's
verify
what
that, please. Instead of
It
just
might be
making these
infinitesimally
claims,
small.
please.
Well, I mean, you're the
Well,
one
the-
who's asserting 0. We're asserting
No,
it's not.
you're asserting that it's greater than 0, but it doesn't completely fall off. So I would like you to verify this for me.
Both sides of this discussion have a burden of proof. For you to say that it is 0 is not the sort of null.
Meter
claim.
says as such. The phenomena says as such. Why would you imply anything
Right, so
else?
why would you trust the meter is infinitely accurate?
The phenomena tells the tale. Yeah.
Okay. No, if that's a good enough measure for you, I guess
So
that's a good enough measure for you.
okay, well, if you can show me something different, I'd be waiting. Why don't you? I'll tell you what. Why don't you take some iron filing dust and throw it around? Maybe take some 1 foot increments and see if you can notice a phenomenary reaction to that. And when you pick up something, holler at me, and we'll go from there, I guess.
Right, but
That'd be your best bet.
What I started by saying is it's a question between whether it is detectable or whether it is actually 0. So if I could detect it, I wouldn't have proven my point. I would have disproven my point. Wouldn't it? If I was saying, oh, I've detected this undetectable thing, that'd be kind of a contradiction in terms, wouldn't it?
I can detect this undetectable thing. I don't understand what you're saying.
The whole discussion is when a Gauss meter reads 0, is for all intents and purposes the magnetic field approximately 0, or is it actually 0.00?
Yeah, it's 0. You could picture it like this invisible balloon that's around it, right? And you're either touching the balloon or you're not touching the balloon.
All right, okay,
Hopefully that helps you.
Yeah.
And then my
see
experiment shows that there is something being picked up as far as a field disparity. But this all goes in to show that this is the connection between the dielectric and the magnetic field. It's a little deeper. So, but if you've never seen this experiment or done it yourself, it's pretty neat and alluring. You should maybe check it out. You could probably do it for under $100. And crickets.
Oh yeah, it doesn't interest me that much. I'm not paying $100 to do it.
Oh yeah, you got it all figured out, bud. All good.
No, I don't have it figured out. I just thought I was going to help split the difference because it seemed like what Kosho was saying was sure detectably it's 0, but in reality it's not. And I wasn't sure if you're aware of that and disagreeing or unaware of what he was saying. The conversation itself doesn't interest me that much. Not enough.
Okay. It should, man. Should. You know, what you thought was gravity is really just magnetic. Really, just a component of magnetism.
Right, but
you'll never know that until you look into it, right?
How so? Well, how so?
Well, I just told you that the magnetic and the dielectric field are connected. So if you don't understand that, then how am I going to explain anything further?
Well, I mean, I've told you this before, and I haven't gotten clarity since then. But I don't know what the dielectric field is, or how it's expressed, or what it even means. Because to me, it doesn't make sense in the sense of what a dielectric or what dielectric even means. It's like a dielectric makes, depending on what that means. Because of what dielectric means, dielectric field doesn't make sense.
Yeah, the dielectric is the ether under torsion, and magnetism is the dissipation, the energy dissipation of that torsion, which manifests the torus, which is, like I told you, the donut shape. And together, like the inverse sides of a coin, of the dielectric and the magnetic right, are the conjugate pairs, the inverse of one another. They're the antithesis of one another, of fields which are but one. So when you have the magnetic field, this is a resultant due to the dielectric field losing its component, which breeds the magnetic field, and vice versa. They kind of feed off each other. And that is what the ether is. It's these two fields together create the ether. And that's nature's geometry of expression.
Okay, but what I'm saying is that dielectric, in the way I understand it, is specifically defining something and how it behaves in an electric field. So a dielectric field, to me, doesn't make sense.
Well, you got to understand what a field is to begin with, because science will tell you that, there's all these separate fields. But in all reality, there's only one field, and that field is the ether perturbation modality, and that being the ether itself. But the ether in a stasis, it has no Cartesian presence reality, which is the only manner by which empirical beings deem anything to be as. So we got to declare the dielectric to be the one fundamental field as manifest, which is the ether under stress or torsion, and the conjugate of the dielectric is magnetism, which itself is the loss of energy of the dielectric, which manifests the toroidal force vectors. It's just as like ice, water, and steam are but one and the same thing, conceptualized as different due to the temperature and molecular pressure. This too is the case for the assumed fields. And electricity is just a hybrid of magnetism and the dielectric, and as such is not a thing in itself, therefore ultimately must be dismissed when speaking of primary subjects or principles. Likewise is the same with the so-called gravity, which is merely point non-specific, incoherent mutual mass acceleration. And yeah, man. So that's simple. Not very complicated. It's literally that fucking simple.
So I'm driving. Yeah, I heard what you said, but it didn't satisfy my confusion when I say that when I, like, at least the way that I know dielectric to be defined, it's describing something as, or a material as its relationship within an electric field specifically. So if you describe a dielectric field as a field itself, it kind of makes the definition, at least the way I understand it, to be meaningless and paradoxical, and kind of, like, it doesn't make much sense to me. So I don't know.
Well, if you just replace the electron with like 1 unit of dielectric inductance, just like J.J. Thomson considered it, then you would understand that literally the electron is nothing more than one terminal n unit line of dielectric induction. And the dielectric manifests and vanishes into counter space, whereas magnetism manifests space itself, which, while having no properties, has the attribute of magnitude and the measure of time or lag. And the plane of inertia is the dielectric, 45 degrees from the magnetic flux and 90 degrees from the geomagnetic precession, whereas force, where the force is inverted to the increasing potential or counter space, the terminal of the dielectric. So the dielectric, like I said, is the ether under torsion, where the magnetic is ether under polarization, which ultimately a true field holography, and that which gives mass and magnitude to all things. So the dielectric and the magnetic are the dimensionalities of the conjugate pair of the total expression of fields, and the versors of or material intermediaries of the conjugate fields, which are time and space, or respectively measure, lag, torsion, and volume. And when I talk about the scalar waves, which ironically contain no wave phenomena, the death ray, this is nothing more than just high voltage dielectric phenomena. So instead of cycles per unit of time, just as like energy beams are measured in voltage per second, the dielectric is the torsional attribute of energy, or the agathon, whereas magnetism is the release of that torsional energy, and therefore is the mirage or projection. So dielectric is the inverse of force. The loss of the dielectric is force or magnetism. The voltage is the dielectric, and current pop is magnetism. And the dielectric has two modalities in losses, so deemed magnetism, and lastly the torsional or cyclical energy is carried in tandem with magnetism, so deemed as electricity and light. So anytime we have electricity, light, or magnetism, these are all constituents of the dielectric field. That being, those two together, magnetic and dielectric field, being the ether. So dielectric is commonly referred to as a medium of dielectric inductance. Most dielectric mediums are literally like clear or transparent. And electromagnetic, I don't want to get into that, but yeah, I'll just leave it at that.
Yeah, fair enough. Sorry, I just realized that Walmart closes in 8 minutes, and I gotta get nails. I mean screws. I've been sitting talking for too long. But yeah, I just I've seen Ken Wheeler's stuff. Honestly, if it won't use the term electromagnetic field, but you will use the term dielectric field, why not just call it an electromagnetic field? I don't know. Makes sense to me, but that's all. I mean, I'm just using the terms they've come up with. It's Benjamin Franklin who made the terms positive and negative, and for the way that he set it up, that's why we call having more electrons being negative, even though it's like the opposite. It's like the electrons are negative. Seems like they should be positive, right? But it's just the way they have it set up. Guess you can call them anything you want, really. Could have called it black and white, but make a difference. Yeah, I got 7 minutes.
Alrighty. Well, how's everyone doing tonight?
Good.
Sweet. Anybody try that the trick that I was telling everyone about a week ago? Anyone try that yet for themselves? The sticking the pencil to the wall. pretty neat. You just take a number 2 pencil. You just place it on the wall. It'll stay there. You could take any pencil, really. Well, I only tried it with the number 2 pencil. But yeah, you just take it, press it firmly against the wall, slide it up a few inches, and let go. You might have to try it a few times, but it'll stay there eventually. Pretty neat. So what do you think about that, if that is possible? Defying gravity right there, man.
Sure, lots of things defy gravity.
Yeah, that's a piece of wood.
Expectations.
I could do it with an eraser, a pencil sharpener, piece of paper.
Oh, excuse me.
Do it with your wife.
Well, I'll get one so you can try.
I just want to make sure you were listening still.
Yeah, I'm just outfitting a ship in Elite, so I'm like trying to stop costing myself money making stupid mistakes.
Hey, Dicelo, have you seen that video I posted? The anti-gravity title.
No.
Okay, check it out. It's short, and you can skip most of it, I think.
So in the chat here or something?
It might be in the chat. Yeah.
Okay, I see it. Let me see. So I got 2 minutes in. It looks good so far. Definitely interested. I gave you a thumbs up, subscribe. I'll have to watch the rest of it in a little bit.
Okay. Yeah, it's not my channel or anything. I'm just passing it along.
Yeah, that guy looks familiar. Lockheed Martin. So, what did he actually do? He put did he say a brass ball into a neodymium magnet or something, and then into a rock, or what?
Well, he was just kind of describing it, and if I remember the description, it was he basically like tied together two $5,000 magnets and used I think a brass ball in the middle of them, kind of keep them at a certain shape, and tied them together, and then like he did a drop test, and it dropped slower. So I guess opposing magnetic fields cause a mass to experience a lack of gravitational acceleration.
Yeah. Ken did a similar one where he drops a magnet down a copper tube.
I know the copper tube is one. That one's way more common, but this one, the way he did it.
Have you seen that? Where you set the copper tube onto a digital
has
scale?
Less weight or what?
Well, it has like virtually no weight until the magnet touches the bottom of the scale.
So the field that's making it go down slow, it is supporting the mass. Is that what you mean? Or
yeah, it's
the field itself, like, and not the copper. Is that what that's proving? So it's basically saying it's not pressure from the air or something like that.
Yeah,
that there is no pressure.
Nobody wants to address that key point, but the fact that all the weight is there upon the scale, but that's not being picked up until the magnet's at rest. So it's kind of interesting. It like a similar concept to what you're talking about.
Yeah. Well, it could be the same kind of thing. I don't know, but the way that this guy does it, he does it in such a way that it it basically related. Well, I guess in his explanation, it related magnetism to gravity directly.
Well, that's what it is. It's the other, like I told you, like magnetism is literally the loss of the dielectric field, and gravity is nothing more than dielectric acceleration. So you can see the connection between magnetism and gravity now is the dielectric field.
Do you describe? Is one way of describing it like the concept of the incoherent magnetism?
Yeah, it's point source versus non-point source.
Okay, so then like everything on Earth has some amount of electrical charge, and it's incoherently attracted to the ground is incoherently attracted, and so everything falls, but it's not necessarily a distinct coherent magnet.
Correct.
So it's just sort of a general magnet.
So kind of like a light bulb is coherent and a laser is incoherent. It's the same concept with point source and non-point source, like pertaining to magnetism and gravity.
Well, I think incoherent magnetism is pretty interesting, because then you just have general attraction, and that's what we experience, just a general attraction.
Yeah, exactly. Yep. But it's not it's not from A to B attraction. It's a curved linear attraction. So no pressure. The two.
You're kind of warping. I don't know if your connection.
Can you hear me any? Yeah. Can you hear me any better?
You could try.
Any better now? I was just saying, it's not mass attracts mass. It's mass attracts mass at the lowest null pressure point. and it's a curved linear relationship. Things don't move from A to B straight. They move curved linear, and they seek the null pressure point between the two masses before they ever come together.
Hmm.
This is why you see fucking orbits and shit like this.
Orbits. Now you've got my interest.
Yeah.
So what kind of orbits are you talking about?
Well, basically any type of orbit, whether it be just magnetic levitation type shit or something oscillating around another two masses spinning around each other, kind of like what's been witnessed with those two celestial bodies coming in close proximity, spinning around each other and processing for quite some time before they ever touched each other and came together. This is all due to the gyromagnetic precession.
So what you should do is you should create a course of understanding, and you should create it. You shouldn't outsource it or anything. You should just make like, okay, this is how to understand this part, and then here's how to understand this part, and here's how to replicate this part, you know, and literally step by step make your point, just so that other people can know what the fuck you're talking about.
Yeah, I'd like to put it into better words and shit.
Because
like
I can
down.
I can follow you to a point, and then it's like, okay. And you know what, honestly, I don't feel like that's my fault. I don't feel like I haven't done the due diligence of trying to understand some of these concepts, but you're just like on a different expression. And I feel like if you were held to it, like if you made coursework, you would have no excuse for explaining yourself. Because at that point, it's fully expressed.
I kind of feel like that's what Ken does, though. That's all
No.
I did was just chew on Ken's words and his definitions and his videos and just try to just beat my head into him.
Yeah, but nobody understands Ken. So if you're trying to be like him, it's not working. Because it doesn't work for him.
Well, I don't know. I think it does. I think a lot of his words are you can easily look them up. You can put the puzzle together if you really wanted to.
Well, do you think maybe like talking to you right now like this is my way of doing that?
I think that's what we do constantly, right? Like, I think if we had it all figured out, there would be no need for us to be discording. I think that's why we rely on each other a lot, conversation, to try to get to better understanding.
Well, at some point, someone's going to have to put together this coursework, is all I'm saying. You know, and the only way we'll know it's right is if it's fully fleshed out, it makes sense, it's replicatable, and gives us something to build on, you know? Like, these Discord talks don't get very far as information flows. I mean, if the future of humanity's understanding rested on Ken Wheeler's videos, we may even understand less. That's what I'm saying.
I don't know, man. Like,
I'm not
it
saying he's
might be a,
wrong. I'm saying that he's just not a communicator.
he's yeah, man. It's hard. It's a rubber stake, but at the end of it, man, is fucking gold.
But how does gold taste? Hopefully not like a rubber stake.
I mean, it takes a lot to chew on and digest. But I would say if you really wanted to understand it, start off with the conjugate geometry, which is literally the physical geometry of the dielectric and the magnetic field and how they're related to one another and inseparable. And then from there, you'll start to, hopefully things will start to help, like they'll start to make sense a little bit further. But if you can't, you'll never understand any of it if you can't understand that part of it.
And you said that was a conjugate what?
The conjugate geometry, the field expression of the dielectric and the magnetic fields, they're the hourglass, which is the hyperboloid, and the torus, which is the donut shape.
Okay,
The
and
inverse,
if I look into that, I'm going to be able to understand what you're talking about. That's what you're
just
saying.
told you. I just gave you lay words, dude. Fucking hourglass. You know what that is? Come on, man.
I know. I'm just
You know what an
asking.
hourglass is? That's the dielectric geometry. Okay. The donut is the torus, donut shape. You know what a donut is? That's the magnetic field. So those two shapes, those two geometries make up both of those fields, and they're inseparable. They're inverse from one another. So anytime you have the donut shape, the negative image, the antithesis of that is the hourglass shape, and vice versa. They're inseparable. They're synonymous. They're attached at the hip. Can't get away from it.
I can feel my power growing.
And this geometry is nature's fundamental force vector. And wrap your head around that, and then we can dive further into that if you want. Gonna get into vortexes and shit. Polarity gets real crazy, but it's fun.
Are you saying you don't want to talk about Coriolis for the 5 billionth time?
I stepped away from bacon in 90 and came back, and they were still going right where they left off. I was like, oh, fuck. That's pretty good, bud. Thank you. I'll share that with the crowd. My son says you gotta eat a. He says the doctors say you gotta eat an apple a day to keep the doctor away.
There was a guy, I think he ate like 10 apples a day, and he lost all of his tooth enamel.
Well, my son says just go eat a doctor a day, or you go eat a doctor because they eat an apple a day or some shit. That was pretty funny.
Yeah, the doctor says, if you want to keep doctors away, as soon as you're done eating an apple, rinse your mouth out to get all the acid and sugar out of there.
Yeah, it's you keep the doctor away, not the dentist.
There you go.
Shit, Alec Baldwin just shot someone.
He would.
Shot someone.
He shot someone on set and killed them.
I mean, not surprised. He's probably one of those mask-wearing VIPs.
He just shot someone in a movie set in Mexico.
Who did this?
Alec Baldwin. He just killed somebody.
Wait, what? Seriously?
Like
How? What? Why?
Just search his name right now. There's going to be like 3 articles at least.
Oh, I'm putting the kids to bed. Just give me the rundown, man. Come on.
Apparently, like, it was a misfire with a prop gun that was supposed to be loaded with blanks.
Oh my god.
He just shot some, like, 46-year-old woman and she died. Some other
That
person.
old gag.
Oh boy, sounds like another Illuminati sacrifice.
I mean, this shit happens all the time, right? Why can't they
Brandon
just?
Lee, bro. Brandon Lee.
Yeah, that's what I was talking about.
Not unlike the set.
Brandon Lee died on set, bro. Crow 2, right? Or no, it was Crow 1, wasn't it?
I think it was the first. Yeah, who's controlling these bullets, man?
Well,
Right?
supposedly
Like-
Alec Baldwin.
Wow. 46, huh? I think that's Illuminati number 2, right?
No, she was 42.
The most important number in the world.
Explains it all.
Yeah, that's even stronger Illuminati number, actually.
Yeah. Take your medicine, schizoid. Well, me, I'm going to take my actual medicine, which is Molly and Coke.
What kind of Coke?
I don't know, the stuff that I just bought from a pizza delivery boy.
Pepsi's better.
No. Like the drug. Like nose candy.
Oh, okay. Nose pizza.
Like any like food delivery person knows at least one plug for drugs, dude.
That's probably highly accurate.
So no, really. Like, go to work at any like food place, and you'll find at least one person who knows where to get drugs.
It's pretty bad, man. Suppose we can go to Oregon and just get it free.
No, I wish, but no. It's just decriminalized. It's not legal when it's just. I wish it was, but whatever.
No, you can go on YouTube right now on Vice channel, and they got a table set up, and they're literally giving away your choice of one of 3 things.
Is it? Oh, free heroin, cocaine, and meth are being distributed to stop overdose.
Yes, correct.
Oh, this is the thing that they're trying to. This is the thing that they're trying to do to get people to gently kind of inch them off the drug. Heroin.
Yeah,
That's
something
too
like that.
that's too hard for me. Meth too hard, but I've done some coke. I'm going to do more coke, but it's not that bad. Have you ever done it before? Like for me, I had to do a shit ton to even get the high. Could have been meant as shitty coke, but it's got this terribly strange phenomena of I think it's called the drip, when it's there's this your nose is kind of numb and it kind of falls back behind your throat. It's an awful feeling.
I don't know. What's so bad about it?
It's it numbs your nostrils, right? Or since you're usually kind of do one line, one nostril. You're not supposed to do it all in one. So your nostrils are numb. And you have this, it's this feeling of something dripping in the back of your throat through your from your nose, right? And it feels just awful. It's just this strange feeling that's just uncomfortable.
That's probably the cut.
Could be.
Yeah. You got some baby lax. So is that all you've done?
Drug-wise? No. Done Molly, LSD. Of course, weed. Everyone's done that, though. Done mushrooms. Those are the ones I've basically done here. I had an opportunity to take DMT once, but I chickened out.
Yeah, I don't blame you. It's one of those things that's just sounds kind of frightening, but at the same time, it doesn't. It's
well, the opportunity was right before we were supposed to leave our campsite for a music festival. I didn't think I was in the right headspace at the time, so I just didn't want to. I didn't think it would be a good high.
Well, technically, you do it every night when you dream.
Nah, I dream very rarely.
Oh, you dream, you just don't remember it.
No. I know that. When I can, okay. When I clearly remember it, I write it down. I have a dream journal.
Sounds like you need more melatonin.
Could be.
Yeah, dreams are great.
Mine have been really bizarre lately.
Yeah, I love dreaming. Well, let's just try to stick to one mic, guys. Not everybody at once. SE, keep that up. I'm gonna have to mute you. All right, that's it, dude. 5-minute mute. Yeah, buddy.
You guys need to see this weird ass house. 11 or almost $12 million.
Yeah. I've been seeing these weird mosquitoes, black and white mosquitoes. Turns out they're the what the fuck are they called? Some kind of tiger. It's an Asian tiger mosquito.
Huh.
Yeah, not good. I guess they carry some gnarly shit. How the fuck they're here in California? I don't know, but I've been seeing them all over, dude. I guess they carry in syphilis and West Nile.